everyone, let's review some concepts from what we did in 21.2 about permutations before we move on to combinations the next lesson. So the first question is, there are 8 marbles in a bag, all different colors. And how many orders can 4 marbles be chosen? That word orders is important because it tells us that order matters, which means we're going to be doing a permutation to calculate this. That's going to be important today because we're going to learn about combinations, so just keep that in mind. All right, so we have 8 marbles, and we are picking 4 of them. So it's just 8 pick 4, and you guys can use the formula or you guys can use your calculator, but that is 1,680 different orders that we can choose for marbles. The next one is, a playlist includes 8 songs, including Kim's favorite and her second favorite. How many different ways can the playlist be shuffled? And then what's the probability that Kim's favorite song will be first and her second favorite song will be second? So this first question is just asking how many outcomes do we have in our sample space. So for our sample space, we have 8 songs, and we're going to play all 8 of them. So we're picking 8. We're seeing how many different orders those 8 songs can be played. So same thing, you guys can use the formula, you guys can use your calculator, but that is 40,320 different ways that this playlist can be shuffled. So now let's talk about the second one, the probability that Kim's favorite song will be the first song played and her second favorite song will be the second. So let's talk about this event. So we basically have 8 songs, right? 1, 2, 3, 4, 5, 6, 7, 8. And we know her favorite song is being played first. We'll just put an F for her first favorite song, and then her second favorite song is going to be played second. So we know that those 2 events have to happen first and second, so we don't really have to worry about the order there. But then we kind of have 6 songs left that need to be shuffled, right? So here we have 6 pick 6, which is 720. So there's 720 different ways that her first favorite song can play first, her second favorite song can play second, and then there's 720 ways we can order the songs after that. So the probability of this event is 720 out of 40,320, which gives us 0.018. So 1.8% chance that her playlist will play her first favorite first, her second favorite second, and then any order after that. The 21.3 is about probability and combinations. In 21.2, we did permutations. They're similar ideas, but remember, permutations, the order of the objects mattered. With combinations, the order of the objects will not matter. So I'll talk more about that in a second. But our goals today are to find the number of combinations and then calculate probabilities involving combinations. So a combination is just a selection of objects in which order is unimportant, unlike permutations where order is important. It has a very similar formula. So if we have n objects and we are choosing r of them, we calculate that. I read this n choose r. We have n objects and we're choosing r of them. So n factorial over r factorial times n minus r factorial. So let's do an example, just a simple one. A person playing poker is dealt 5 cards. How many different hands could the player have been dealt? So here, order is not important, right? You get your deck of, you get your 5 cards, your hand of 5 cards. You don't care what order they got to you in. You just have 5 cards in your hand. So this is an example of when order does not matter. A deck of cards has 52 cards. So we have 52 cards and we're choosing 5 of them to deal out. So again, you guys can use the formula if you guys would want. It would be 52 factorial over 5 factorial times, and then 52 minus 5 is 47, so 47 factorial. So if you're using your calculator, make sure you put that in parentheses. Your calculator also has this combination function in it. So if you go to math and then probability, you'll see that function. I think it's, let me look really fast. It's number 3. Okay. So you can use that function as well. So 52 choose 5, we get 2,598,960. So a lot of different possible hands that we can deal in poker. Let's do an example where we're using combinations to calculate probabilities. So there are 4 boys and 8 girls on a debate team. The coach randomly chooses 3 students to participate in a competition. What's the probability that the coach chooses all girls? So again, whenever we're working with probabilities, let's first calculate our sample space. So our sample space is just all possible ways that this coach can choose 3 students to participate in this debate team. Again, order doesn't matter here because 3 kids are going to a competition. It doesn't matter who goes first, who goes second. They're going as a group of 3. So we have 12 kids, right? We have the 4 boys and the 8 girls. And we're choosing 3 of them to go on this competition. So that is 220 different combinations of students that we can pick to go on this debate trip, wherever they're going. And now let's talk about our event. We're concerned with the probability that he chooses all girls. So we have 8 girls, and we would have to choose all 3 girls to go. So 8 choose 3 gives us 56. So the probability that he chooses all girls, our event has 56 outcomes in it. Our sample space has 220, so 56 out of 220 is 0.254. There's basically a 25% chance that he's going to pick all girls to go on this debate team trip. Let's do another example where we do probability using combinations. This is kind of a similar problem. We have 4 cards that are randomly drawn from a standard deck. What's the probability that all 4 cards are diamonds? So let's talk about our sample space. This is just all possible 4-card hands. So we have 52 cards, and we are choosing 4 of them. So again, just plug that into your calculator, and we get 270,725 different 4-card hands that we can be dealt. Our event is that we get all diamonds. So remember, there's 13 diamonds in a deck of cards. There's 13 of each suit. So our event we're concerned with, we have 13 diamonds, and we are choosing all 4 cards to be diamonds. So again, plug that into your calculator. 13 choose 4 is 715. So then the probability that we get all diamonds, we take the outcomes in our event, which is 715, and we divide by the number of outcomes in our sample space, which is 270,725. And we get 0.003, which is 0.3%. So very, very low chance that you are going to get all diamonds in your hand of 4 cards. Sometimes when we're doing these counting problems or these probability problems, the question will have phrases such as at least or at most. So for these problems, you're going to have to add different combinations together. So let's do an example. Suppose a coin is flipped 3 times. Find the number of combinations with at least 2 heads. So at least 2. So remember, we're flipping this coin 3 times, okay? So this phrase at least 2 includes 2 possible outcomes. It includes 2 heads or it includes 3 heads. Those are kind of the 2 outcomes that satisfy at least 2. So we're flipping the coin 2 times. We're flipping the coin 3 times, so we'll have 3 choose 2. Okay, that's for this first one. And then we'll also have 3 choose 3. We're flipping the coin 3 times, and we're choosing all 3 to be heads. So we have to add these 2 combinations together to kind of satisfy this phrase at least 2. So 3 choose 2 is 3. 3 choose 3 is 1. So there's a total of 4 different ways that we can get at least 2 heads. And if you guys want to look at that visually, 3 choose 3 looks like this. You flip heads 3 times in a row. There's no other way to do that. This other one, 3 choose 2, we could have 2 heads first and then tails. We could have heads, tails, heads, and then we can also have tails, heads, heads. So those are kind of our 4 possibilities for getting at least 2 heads, and you can see that that's what we got when we used combinations to calculate it. All right, for our last example, let's do a probability involving combinations and addition. So math department has a large database of true-false questions, half of which are true, half of which are false. So basically what that's saying is we have a 50% chance of choosing a true question from the database and a 50% chance of choosing a false question from the database. A new test is created by randomly selecting 6 questions from that database. What's the probability that the new test contains at most 2 questions where the correct answer is true? So here's that phrase we're concerned with, at most. So let's talk about what events satisfy at most. So at most 2 questions being true. One option is we have 0 that are true. Okay, so we have 6 questions we're making, and we're choosing 0 of them to be true. So that is one way to do that. Another outcome that satisfies at most 2 questions being true is if one event is true. So that's 6 choose 1, which there's 6 ways to choose, have 6 questions and choose 1 to be true. And then the final event that satisfies at most 2 is if 2 events are true. So 6 choose 2, and 6 choose 2 is 15. So there is a total of 22 combinations of at most 2 questions being true. Okay, so that's kind of how many outcomes we have in our specific event here. So now let's talk about our sample space. So this is a little different. We have 6 questions, right? I'm going to kind of draw this out. 1, 2, 3, 4, 5, 6. Now each question has kind of 2 options for its outcome. It's either true or it's false. So we have 2 options for the first question, 2 options for the second, 2 options for the third, 2 options for the fourth, 2 for the fifth, and 2 for the sixth. And what we do is we multiply all of those together to figure out how many outcomes there are in our sample space. So this is really just 2 to the 6th power. That's a 6 up there, by the way. 2 to the 6th power, which is 64 possible outcomes in our sample space. That's how many different combinations we can have of true-false questions. So the probability that we get at most 2 that are true, we'll do the outcomes in our event, which we have 22 outcomes in our event, divided by the outcomes in our sample space, which is 64. So that is 0.344. There's a 34.4% chance that we'll get at most 2 true questions. All right, that was the last example. So if you guys have questions, make sure you guys turn into our virtual office hours, or you guys can send me an email. And then this week, you guys also have 21.4 to do as well. So I hope you guys have a good day.